design and built environment, Kingswood, Western Sydney University in Australia. And as I mentioned, he leads the group on nutrient, energy, water, and material recycling, which is very, very important from circular economy point of view. And he has over 170 publications in journals, conference papers, and so forth. He also has a lot of research money. So before that, I wanted to mention that he graduated several PhD students and master students. So he has received over 3.4 million in research funding. He has led and is currently leading several major research projects funded by industry. And he's well known for food waste recycling and commercializing the opportunities for industry partners. You will see, from this presentation, his research is actually has a, practical impact nationally as well as internationally. So he's also works on recycled water for irrigation, which is a very important topic these days, because of the drought or, conservation of water efforts. So that's also a very interesting topic. And he has been working with research groups from different countries, Australia, India, and the US. So he's a co-leader and co-founder of Australia India Water Center, and which is very active. So there are 10 Australian and 18 Indian universities and government departments. So that's a huge accomplishment. So he's doing a lot of research projects related to springs regeneration as well as wastewater recycling. So in addition to that, he has been undertaking a lot of activities for capacity building in Australia as well as in Indian universities. So I happened to visit his university. It's a Center for Infrastructure Engineering. So it's wonderful. And the campus is very nice. You can see, everywhere green. And of course, when we went there, it was in November, but it was summer there, super hot. And he also has a very nice lab doing all these reactor experiments. And then he also has an outdoor research lab for and doing the real research to translate into the practice. So with that brief introduction, I want to thank again Dr. Dharma Hagare for agreeing to present this webinar. And I want to thank you all for joining in spite of this being not our regular time. And I hope you can enjoy the webinar and learn something new. With that brief introduction, I request Dr. Dharma Hagare to share the screen and start his presentation. Thank you so much, everyone.
Okay. Yeah, thanks very much, Krishna. Thanks very much for that great introduction. You can hear me?
Yeah.
Yeah. Okay. Fantastic. Yeah. Thanks very much, and nice to see quite a people out there joining this particular webinar. As Krishna said, I'm going to talk about circular economy opportunities in managing the organic waste. Now, I'm leading a group called Nutrient Energy, Water and Materials Recycling Group, which we call it a NEWMARG. So that's a new ways of doing things. So as a part of NEWMARG, we've got a large group working here in the university. So at this stage, I've got about 12 PhD students and 2 postdocs working with me. So there are 3 areas we are concentrating at this stage: recycling of nutrients contained in the wastewater and solid waste, and food and garden organics recycling, and also plastic waste recycling. But my focus today is on food, garden organics, recycling. That's what I'll be talking about. Organic waste. It's a massive amount of organic waste which is produced. In 2020-21, Australia produced about 14.5 million tons of organic waste, out of which 4.7, around 5 million tons is estimated to be food waste. And out of that, almost 4 tons is sent to the landfill, which contributes almost up to 3 tons per ton of waste, which is sent to 3 tons of carbon dioxide emission per ton of food waste sent to landfill. It's a huge amount of the carbon emission there. Now the governments have realized this is a high time that we do something about this. So now we have got some policies on the recycling of this organic waste. For me, sending organic waste to the landfill is a waste of resources. It has got a lot of energy, it has got a lot of nutrients, it has got a lot of good things there. So I think it's a matter of putting our thinking brain together to come up with ways by which we can recycle this material. It's a resource, it is not a waste. We should be doing a lot more to recycle this particular material. Now in Australia, we have got what is known as a 3-bin policy. In most councils, we have the 3 bins. So one is a red bin, which is a general waste, which is normally picked up every week. And then you've got a green bin, which is mainly garden waste, which picked up once in 2 weeks. And then yellow bin, mainly recyclables, which has got paper, plastic, metal, glass. And that also picked up once in 2 weeks. Now there is a change now. So now the most councils and the governments, so state governments, are going towards using a green bin, which includes both the garden waste and the food waste. And they want to collect this particular bin once in a week, and then try to process it, and then try to recycle all the material. So as far as the organic waste is concerned, we basically have got 3 main sources: the commercial and industrial operations, like restaurants and the food processors, food manufacturers, and so on. And then agriculture farmland, which produces more of the residues, agriculture residue, and then the residential houses, which includes the food organics and also the garden organics. And now in Australia we call it as FOGO, which has got typically about 10% food organics and 90% garden organics. Now, our state government, NSW state government, has come up with a target of diverting 50% of the FOGO material away from the landfills by 2030. We're not sure they will be able to achieve this particular target, but at this stage, the first thing the most councils has to do is to put both the food waste and the garden waste into one bin. So that's what they're doing at this stage. Most of the councils are going into a green bin, which includes both the food waste and the garden waste. Now, there are lots of commercial operations, commercial places where they produce, quite a significant amount of, the food waste. in the world, we waste a lot of food material. So yeah, particularly one of this market, which is in right in the center of city, it produces around 3 to 5 tons of food waste, per week. That's a massive amount. And unfortunately, all that is going to the the landfill at this stage. So that's what that's what we want to do. We want to recycle that particular material. Now, out of this, the recycling, we picked up this, food waste to chicken feed, the pathway. Um, Again, this is mainly because of our commercial partner who came along and said, this is what we want to do. So we have been working with them since 2017. Now, why chicken feed? Poultry makes up 26% of the meat production in Australia. In 2019, 1,240 tons of chicken meat was produced. So imagine how much, the chicken feed we need to produce to feed this chicken. So at this stage, the chicken feed is mainly from the wheat-based or barley-based or sorghum-based feed, which is around 370 to $410 Australian dollars per ton. So that's the current price for these basically fresh food-based feed. Now in Australia, so particularly in New South Wales, any food waste goes into from the commercial operators. Any food waste goes to the landfill. They need to pay around $350 per ton. So what that means, now we basically have got about $750 per ton as uh, the amount within which we can, if we can take the food waste, transport it and process it, and then sell it. So the whole, the cost has to be under $750 per ton. Now the company with whom I'm working, they are saying that they can do the entire thing under $500 per ton. So there is a huge margin which they're able to achieve. So I think this would be the best option for recycling the food waste from commercial operators. Now, moreover, the carbon emission saving, there's a huge carbon emission saving. So if you look at the emission saving, the animal feed sits right on the top. So, if you put, send it to a landfill without any capture, that's around 3 tons. And if we can recycle, you're going to offset 347 tons. So there is going to be almost 3.5 tons of carbon emission you can save by recycling the food waste via the animal feed. So which is the most preferred even compared to the anaerobic digestion. Now the food waste chicken feed is not a new thing. It has been informally practiced around the world. I'm sure in India it is being widely used. Only thing is it is not done in a commercial scale, in an organized scale. So that's what we want to sort of achieve through this particular intervention. So we want to organize the entire sector to produce chicken feed from the food waste. So hopefully that through that we'll be able to achieve near to 100% recycling of all the commercial food waste in the world. So this particular project came about from in collaboration with Food Recycle. Now this is a startup company started in 2016, I think. So they came to us in 2017. So since 2017, we have been working with them. So now they're pretty much tied up with quite a few big companies like Sumitomo and a few others. So they're now in the process of establishing commercial the plants around the world, not just in Australia, around the world. So what is the process? The process is very simple. So you collect the food waste, do the collection, and take it to a manufacturing center, do the weighing and sorting, heat treatment, and then you've got a grinding and mincing, and then again drying and grinding, and then pelletizing. So finally you'll get a chicken feed. It's a very, very simple process. I guess the critical issue here is blending different wastes together and making sure the food waste hasn't gone nasty. It means it's no bad microorganisms have infested that food waste. So those are some the biohazardous issues we need to address in this particular work. Now, in terms of nutrient requirement, we need to make sure that the protein is around 18 to 23%. Crude fat is above 5%. Energy is around 11.5 megajoules per kg. And then you got all this the cations, calcium, magnesium, potassium, and as you know, calcium, the significant levels of calcium they need to have, and also the other nutrients like iron, copper, and also they need some amino acids. So these are some of the different amino acids. So we need to make sure that they're there in the feed. All these are kind of set out in our NRC guidelines, which are used to prepare the feed for the chickens. So in order to achieve that, the mix of different, in order to achieve that, the final nutrient value in the chicken feed. So what we need to do is we need to bring together, 2 or 3 or 4, different types of waste material, food waste, and then combine them together in order to produce a nutrient that is required for the chicken feed. So that's what we have done initially. So now we are continuing that on waste profiling. So what we have done now, and we are still doing, is collecting different waste material for different operations, commercial operations, and then we are doing characterizing work. So we have done some of these the materials like duckweed. Duckweed was collected from the ponds, cowhide from the abattoirs, fish offal, hospital, nursing home, the food waste. Even the oyster shell, we have done some characterizing work. Bakery, butcher shop, pub and hotel, restaurants, cafes, and earlier I said about city markets, where they have got fruit and vegetables, and also the fish comes from there. So several types of grains we have done, and kangaroo meat. So Australia is known for kangaroos. Now kangaroo is also a game meat here. So people do consume kangaroo meat. So that we have tested that meat and bone as well. Boar meat and bone, retail fruit and vegetables, paunch waste that's from the abattoirs, and also spent previous grain, so which is mainly from the beer making factories. So these are different ones we have done. We have done a few more as well. Just included a few of them here. So we have done protein, fat, ketones, and metals characterization, and also amino acids for all these, the food waste materials. Now the huge amount of work has gone through, but we'll not be able to present everything yet. So just show you few of those. So, for example, in the case of restaurant, cafe, and fish markets, and fruit and vegetable markets, you can see that there is a huge variation in the protein content, crude fat content, and also the energy content. So as far as the guideline is concerned, we want to have around 23% protein, um, which the only few of them are able to satisfy yet. Only the fish has got the required amount of protein there. Where the crude fat, I think pretty much most of them will be able to satisfy. And energy content, most of them will be able to satisfy. So I think what we have realized through our characterization work, protein is one of the protein and amino acids. These are the two nutrient requirements. Only few food waste will be able to satisfy. So that's why mixing together different waste streams is very, very important. You can also see that amino acids can vary drastically from one waste to the another waste. So there are some, got a good amount of amino acids, and some do not have much at all. So that blending together different ways is going to be very important in this exercise. And also as you all know, the food waste type can vary drastically with respect to time, the seasons. So for example, in one of the restaurants, we have done some the characterization on different dates. So the May and June is like our, around winter time here. And then you got the November is around springtime here. So you can see that the winter time and the springtime, there's quite a considerable difference in the characteristics of the food waste in terms of protein, fat, and energy content. So this gives us additional challenge in terms of how we can combine this together in order to produce a balanced the feed for the chickens. So adaptive kind of a quickly adaptive type of formula we need to come up with in order to work out what percentage of each stream it needs to be merged together in order to produce a balanced diet for the chickens. So that's why we are looking at now is developing a kind of an app which can give us work out what proportion of each of the stream can be combined together in order to get that a good balance diet for the chickens. We did some feed trials. This was done by one of our partners, University of New England, which is located in one of the regional areas of New South Wales. So that we tried a particular type of hens, 150 of them. So 3 types of feed were fed between weeks 24 and 43. So there are 3 different feed were chosen. One is a control feed, which is a normal, fresh, the agriculture produce feed, which includes wheat, sorghum, and soybean meal. And then the next is 100% food waste feed, which includes quite a few different waste streams. And then we had a 50-50. So 50% the control feed and 50% the food waste. So this is a full listing of all the nutrients in that control feed, food waste feed, and blend feed. So there was the slight variation between between the feed between 24 and 37 week and 38 and 43 week. So it's mainly related to the protein content. I think the hens would need higher protein during the initial stages, and it's kind of weaned off in the later stages. So this gives a complete list of all the nutrients which are provided to the hens in all 3 in all 3 diets. So so we looked at the hen weight. So in the hen weight, you can see that there is some slight variation in week 29 and 39, but generally you can say that there's no variation between the control feed waste, food waste, and 50-50 blend. So that's all 3 kind of result in a similar growth in the hens. We also looked at the egg production. So you can see that egg weight, individual egg weight was similar in all 3 feeds. The difference was in the amount of feed provided to the hens. You can see that the amount of feed provided with the food waste was the minimum compared to the control. So you can see that the feed produced from the food waste, the requirement of feed produced by the food waste can be lower than the commercial, the chicken feed which you get from the market. So this could be a added advantage in using the chicken feed derived from the food waste. We also worked on using the food waste to produce a liquid fertilizer. This is a kind of a byproduct which we produced, but later onwards, we sort of modified the entire process to produce only the chicken feed. But initially, we had this liquid fertilizer being produced as one of the byproduct. And in fact, we realized that even the liquid fertilizer can become a very good source for hydroponic, growing the plants in hydroponics. So we did a small trial here to grow our lettuce, cucumber, and tomatoes using this particular liquid fertilizer. We did a comparative study between the commercial liquid fertilizer and the liquid fertilizer from this from the food waste, and we grew this in small greenhouse, and we can see that the growth between if we compare the growth between the organic liquid fertilizer and commercial liquid fertilizer, they're very similar. So here the wet weight was 156.3 and 161.3 here. And the dry weight is around 30 here, 32. So there's not much difference between both, both the trials. So that means that, we can use liquid fertilizer derived from the food waste for in the hydroponics to grow vegetables. Now, the one other project we also working on is the biomethane potential for FOGO. Now, as I said, the NSW government has got a target of diverting 50% of the FOGO by 2030 away from the landfill. So there's there's a lot of emphasis now to recycle the FOGO, either for energy purpose or for the fertilizer or any other purpose. So we are working on this now. So what we have done is we collected the food waste and the garden waste. We did the mechanical grinding, and this is ground material. And then we have done a batch study where we put them into the flask and did the digestion. So we are doing a dry digestion. So there is a difference between the dry digestion and the wet digestion. In the dry digestion, we try to maintain the solids content around 15 to 20%, whereas the wet digestion will be less than 5%. Now, why dry digestion? Dry digestion is, especially FOGO, is going to be more economical because if you want to achieve a wet digestion for a FOGO, you need to add, lots of water. So by adding water, you increasing the volume of the reactor, and the capital cost, goes, quite high. So that's why the dry digestion is going to be very, very helpful. So we are able to achieve around 17% total solids solids content in the reactor, which is very good. Anything between 15 and 20% is good for a dry digestion. In fact, this technology could be used, to for the stubble in India. So they're now having a problem of the burning that stubble and creating air pollution. So this could be one of the solutions for that. I think the issue with anaerobic digestion is cellulose, lignin, and demicellulose content. Particularly we have realized that if you're just using the garden waste and grass and leaves and twigs, your cellulose content is quite high. It's almost 50%. And also it has got hemicellulose content and the lignin content. So these three things make it very hard to digest. But that's where we bring in the food waste to accelerate the process. So there's quite a bit of work to be done in this area. So this is one what we are working on. And the food waste, you can see that it produces methane very quick. So this is the one, the food waste. And the garden waste, grass and leaves and twigs, normally takes a bit of time to produce the biogas. We were able to produce around 69 to 146 ml per gram of VS fed. which is typically the what kind of observed in other by other researchers. So now what we are looking at is how we can sort of adjust the C/N ratio in order to increase this production rate and also increase the VS destruction. Now, one other project we are working on is use of the organic waste for bricks. We are looking at because the bin what I was talking about has got a FOGO, which has got 10% food waste and 90% garden organics. So what we are trying to do is we are trying to use a percentage of that, blend it with the soil, with the clay, and then produce brick. So we've been working on this for the last 3 years. There are some emission issues which we are trying to work that out. So hopefully we will be able to use another way of recycling FOGO in the urban areas. So this is all circular economy. So what we are trying to do is, we are trying to use the waste produced by in the food production industry, food processing industry, and the domestic and commercial industrial activities. So all that food waste and the wastewater which is produced, in the case of wastewater, we want to recover the nutrients and recycle it back to the food production. And in the case of food waste, we want to produce animal feed and the other applications as I discussed. So it's if we can achieve a closed loop circulation of the materials and the nutrients, I think that's a great achievement. Now, in a circular economy, you really have to have a collaboration. So you can't just do it by yourself. So you need to bring the community, and you need to bring the industry partners, and you need to bring the government. So if we bring all of them together with a research organization, we'll be able to achieve circular economy outcome. It's not going to be easy because quite often you need to economically justify some of these projects. But if you put a bit of an investment and some new ideas, we'll be able to achieve these, the complete recycling of the material, particularly in the organic waste. I'm sure that we'll be able to achieve 100% recycling in whatever the country you're in. It's a matter of bringing together the like-minded people and then working together. So if we work in a truly collaborative way, we'll be able to achieve this, a good circular economy outcome. So gratefully acknowledge, the Food Recycle Limited, particularly they have given us a lot of support, and also 2 of my students who have been working on this particular project for quite some time now. Okay, thank you, and let me stop sharing.
That's a very interesting presentation. Thank you so